Hi, welcome to the last section of the course, Watching Your Network. In this section, we will start with setting up centralized logging, then install a Snort IDS. After that, we will be managing your Snort rules, and finally managing Snort logging. So let's begin with the first video of this section, setting up centralized logging. In this video, we will configure your central server to accept messages via UDP and configure your other systems to forward their messages on that system via UDP. Linux servers are typically configured to use a syslog-based logging system for handling events. There is a wide collection of syslog implementations, each with their own take on log handling. By default, Ubuntu servers are configured with rsyslog, which is a fast and featureful syslog implementation. The configuration for rsyslog is defined in etc rsyslog.config, as well as in any star.config files included in etc rsyslog.d. If you look in etc rsyslog.d 50-default.config, you will see configuration entries like this as highlighted. If you look in the left-handed side, it shows the facility servity of the slog events. You can specify more than one of them using a comma separating the values. The syslog protocol allows for 24 different facilities, including ones detected for kernel messages, mail messages, user messages, and a variety of locally defined message types. The severity ranges from emergency at severity 0 to debug at severity 7. The right-hand side shows the destination of the message. In both of these examples, the messages are being logged to a file. The first example logs messages to var log auth.log. After each line is completed, the service calls sync in order to ensure that the messages are written to disk. The second example includes a before var log syslog in order to signify the sync calls should be omitted. Logging with the sync calls omitted operates faster, but at the expense of potentially losing log entries during a system crash. Input methods. The stock Ubuntu configuration only uses Unix sockets and kernel messages for receiving syslog data. rsyslog itself is additionally have to read messages via TCP or UDP ports, though reading plain text log files are directly from system. Output methods. rsyslog has more output options than it has input options. In addition to logging to plain text files, rsyslog can log to a variety of databases, the systemd logger, pipes, SNMP, or the other syslog servers over TCP or UDP. By setting a specific server to accept syslog messages via TCP or UDP, you can choose to forward copies of messages from all your servers to a central logging location. Now we will see how to do it. Configure your central server to accept messages via UDP by uncommenting the following lines in etc rsyslog.config. Configure your other systems to forward their messages on that system via UDP by adding the following to a file in etc rsyslog.d. Now let's see how it works. Modload tells rsyslog to load a particular module. In this case, we're loading the UDP input module. In order for rsyslog to actually start listening though, you must define the port to listen on by setting UDP server run. The UDP port assigned from the Internet Assigned Numbers Authority, IANA, is 514, so we are going to use that for the value. On the logger side of the equation, things are much simpler. Just define the facility.severity that you want to log remotely, and specify at target. The target name can be a host name or an IP address. In this case, I am forwarding messages to our router. It could very well make sense to have the log server to be a dedicated box that even the router can send its messages to. If you want to use TCP rather than UDP, you simply need to mode load IMTCP instead and define input TCP server run, and then specify your logging target as at 10.0.0.1 instead of at 10.0.0.1. The choice between TCP and UDP will depend on your needs. UDP is fast and does not require an established TCP connection, which could potentially be a limited resource on your system. More devices also very well support it, since it tends to be the default choice. As a downside, however, it is trivial to spoof the source of, which could potentially lead to someone giving you false logs. It is also impossible to notice if you have dropped messages. Using TCP instead provides you the additional reliability of a connection-based protocol and the added spoof protection of the TCP three-way handshake. It can also be tunneled through the proxies or wrapped in TLS to provide authentication of the server and client. Great! In this video, we have set up centralized logging. In our next video, we will be installing a Snort IDS.